Okay, this presentation is meant to be part of CNT 6418 at University of Central Florida, and this is for the second week of class. We're talking about Linux and sort of an overview of how to use Linux because a lot of people in class are not very familiar. So let's go ahead and get started. We're going to copy and move files. So let's go ahead and open up a terminal. Okay. And remember what we said, that the desktop is actually a directory that's within the home directory, okay? Which means every user is going to get their own desktop, every logged in user. So we also said to get into the desktop from here, we just say cd desktop, change directory in other words, and this is a relative, this is cd, we're going to cd into a relative directory. So now we're in the desktop directory. Just one thing to point out, you'll notice that the path says tilde slash and then desktop, and the tilde indicates the home directory. So I want to point out something real quick about the path that you see here. You see tilde slash desktop. Okay. The tilde means the home directory. The slash means from the bottom of the home directory. So tilde desktop just means that you're referencing everything off of the home directory. So let's take a look at what we have here. Okay, we have all those. You can see the files out here in the desktop, and this is going to be similar to Windows, the way Windows has things. This is going to be similar to a command prompt or PowerShell, or whatever your choice is going to be. So let's talk about copying files. First, let's make a directory. mkdir, and I'm going to say Porsche Pictures. Okay, if I do an ls, there is a folder named Porsche Pictures. Now, in order to get into that, relative to desktop, Porsche I do an ls. Okay. Now, remember we said to backup, you say cd ... You can also say cd tilde / desktop / Porsche Pictures, and basically what that's would be considered an absolute path. Okay. So let me go back into the desktop directory. All right. So now what we want to do, so cp is the copy command. So we're going to copy that one picture in. Actually, it needs to be capital P. This needs to be. So these, by and large, are going to be case sensitive. Okay. So if I say ls Porsche Pictures, I should see the contents of that Porsche Pictures folder directory. Okay. Now I can continue copying these files over. And this is not the best way to do it, by the way, but I'm just showing you for argument completion. So we have 5. So now, all 5 of those pictures should have been copied into here. Okay, yeah, and sure enough they are. Okay, so let's go ahead and get rid of these real quick. Okay, so that was not the best way to do it. There's a notion called a wildcard. So there are 2 types of wildcard. There's the asterisk, which means anything from that point on that matches, or there's the question mark, which means anything just representing that single character. Okay, so let's say I have, I'm gonna amend this just a little bit to make my point. Porsche 1 auto.jpg. Let's say it was all like this. Oops. Oh, it's not. So what I could do to match all those, I could say Porsche star, and that means everything after the Porsche in the root. So this, or even if it was this, it would still match because it would be anything from there on that would match .jpg. Okay, so the asterisk is going to match anything forward. Let me change this back to. But I can match a single character with Porsche question auto.jpg. That would match everything that except for that would be completely wild. Okay, so let's go ahead and show you that. Copy Porsche. And if I say star.jpg to Porsche pictures, all of those Porsche files are going to get copied in. If we open this, we should see them all. Okay, we'll go ahead and remove those for sake of argument. Now, I can also do it with a question mark since all we're matching is a single. Okay. Okay, so that's copy. That's copy, and then the wildcard idea we've talked about. Now let's talk about moving files. So MV is the same as copy. Let's make that an MV. The only difference is instead of actually making a copy, it's actually going to move it. So if I do this, those Porsche pictures will be removed from the desktop and placed into the Porsche pictures directory. Okay, so they're gone from the desktop, but they are here. Okay, let me go ahead and put those back. You can actually do a cut and paste if you want. Okay, so that's move. Now, so we already talked about making directories. How do you remove directories? Okay, so let's go ahead and remove the Porsche pictures directory. rmdir Porsche pictures. That. So it didn't work, and the reason it didn't work is because there are already files in the Porsche pictures folder. So before we even do that, we need to remove all the files. So we say remove. Okay, so let's open this up. Everything's gone. rmdir Porsche pictures. So the directory is gone. Okay, so I'm going to put another file in here that we can experiment with. It's going to be called declaration.txt. And this just has the Declaration of Independence in a text file. So one of the things you can do anytime you have a text file is run a really simple viewer here. And this will give you a really easy way to run through and kind of read this. You can page up, page down, arrow up, arrow down. So this is really, so hit Q to quit. So that's a really nice utility. But you can also search. Okay, so let's go ahead and search. We're going to use the grep utility. We're going to search for the word free, or the text free, declaration txt. Okay, so it shows us all the copies of free it found. Grep actually has quite a few. So feel free to look at grep. It's a really convenient way. For instance, okay, so I'm going to put another text file out there, other.txt. And I can also do grep free star.txt. And it's going to actually look in both files and try to find a match. So this is really useful when you're trying to find files in a certain folder or directory that have a certain text string. Okay, so now we're going to talk about redirection a bit. And we can redirect into a utility or out of a utility. So let's start off with a sort utility, which is part of Linux. You need a little help just by doing that. So anyway, I've got a file on the desktop sort list. Okay, and we're going to go ahead and run the sort utility, but here we're going to pipe sort list.txt into that. And the key is this little lesson symbol here, kind of showing the direction. So now it sorts it and displays it on the screen, and in a sorted way. And here again, you can actually sort descending, and there are lots of options here. Okay. And this is actually maybe one of the most useful things. grep. We've already kind of done this. Look for free. Star.txt. We've already done that. You've seen the output for that. But now let's pipe that into search results.txt. Okay, that way I don't have to look through it at the command prompt. Or I can say less search results.txt like that. So to make this even easier, instead of piping grep into a file, I can actually put it directly into less. Okay, and that vertical bar is called a pipe. That's going to pipe the results of grep free star.txt into less. Okay, and so now I can look at whatever the results are. Now there might be times when instead of creating a file, such as search results.txt, you actually want to append to a file. So if we say grep, say Alice question.mp3, we want to search all the Alice files for the word free, which I'm sure we wouldn't find them there. And we want to append it to search results.txt. So instead of creating search results.txt, it'll go ahead and append it. Of course, it didn't find anything, just because those are MP3 files, and pretty much, unless there's some sort of metadata in there, it's only going to be binary sound data. So a lot of times in Windows, the file extensions are actually hidden. And so a lot of times Windows users don't get used to even dealing with file extensions. But if you'll notice, all of these have file extensions: MP3, JPEG, TXT. So the first thing I need to tell you is that by convention, it is really, really helpful to have something with an extension, such as MP3, JPEG. Okay. Now, I'm sure you noticed when I created this folder, I said make dir Porsche pictures. So it's not necessarily a great idea to have like blanks. So if I copy alice1.mp3 to alice1.mp3, it's not going to like it because of that blank space. I could actually put this in quote marks, and that would actually work. However, what I'm going to recommend that instead of blank spaces, you go ahead and use underscores. It's just more readable, and it's just more of a tradition in name conventions. You could actually use a dash too. So even though you can use a blank space, what happens is either you or other people have to end up using these quote marks. So it's just better to use either an underscore or a dash instead of a blank space. Okay, so now let's go ahead and talk about some other useful Linux commands. The first one is gzip. Gzip takes a file and creates an archive for it. And in Windows, there's sort of a similar thing where you right-click on a file and say send to compressed file. So if I say gzip declaration.txt, you'll see that it created this zip file with a .gz. In Windows, it would be a .zip. Okay, so now what we want to do is we want to unzip that. Let's see,gunzip. We need to decorate that with a gz extension, and it reverts back to what it was. So you notice what it did was it did not keep the original file. So if I want to keep it, I say -key K, and it keeps the original file. And let me go ahead and rename that. You can also do that with the unzip too. So if I say gunzip -k declaration.txt.gz, it'll also keep the original file there. Okay, so you're definitely going to want to remember that, because for whatever reason it automatically removes the original file. Put this back, restore this. Okay. Zcat is going to actually show some sort of a zip file without actually uncompressing it. So if I say zcat declaration.txt.gz, it'll show me what's in that file. That's the Declaration of Independence. Of course, that's really inconvenient. So we've already learned about the pipe. So if I can just say less like this, it gives me a really convenient way to read it. So that's a really nice way to read what's in a zip file without having to actually unzip it. And you have a nice pipe mechanism that you can use to read it with. Okay, file. We're just going to look at all files, and it gives you really pretty much the nitty-gritty information about a file such as the EXIF data. Notice Porsche3.jpg. EXIF data is this metadata that covers stuff like the manufacturer of the camera, the model of the camera, the orientation, and so forth. I mean, there's a lot of information. And there are actually utilities that even you can use to display the EXIF data. I don't see it here, but a lot of times you can actually get GPS data and EXIF data if it's from a phone or something. These Porsche pictures were actually taken with a fairly old digital camera. Okay. Diff, clear this. Diff is going to show you the difference between two files, declaration.txt, other.txt. So it shows you, it does a comparison of these two files. Okay, and if you want, here again, you can type it into less, so you have an easier time of reading it. Okay.
I'm going to show you how to set the permissions for Linux systems on files and directories. First thing we need to do is take a look at what the permission set looks like and understand how to read the permissions of files. I am currently logged in as root on my Halverson Fedora Linux computer. I am going to type cd/. That will take me to the root of the file system and do an ls-l. And this will give me a directory listing of all of the files and mostly directories that exist on my system. What we're going to focus on is this portion right here. The first part of the listing will use this Morpheus directory that I created. I know that it's a directory because if I look at this first section of my directory listing, I see a D represented here. That D identifies that this is a directory. If it were a dash, it would identify it as a normal file. And we will see that example here in a minute. The next three identify a read, write, or execute permission set. That read, write, and execute are the only three permissions that you can set on a directory or a file. And those first set of read, write, and execute are applied to this, the user who owns that directory. So we have a user on this system named Beth who owns the Morpheus folder. Beth, the user and owner, has read, write, and execute. Read permissions allow Beth to see that directory and the contents of it. Write allows Beth to modify that directory and the contents of it, which also means deleting files or directories. And execute means that she's able to execute files that are scripts or programs. And a little caveat to that is that all directories need to be executable in order to open them and see the contents of them. So every directory that you see will have executable rights for the user or the group in order to make sure that it can be opened and the contents can be viewed. Again, read, write, execute. This first grouping of read, write, execute are assigned for this user who owns it. This is the owner of that file or directory. The next set of three, read, write, and execute, are for the group that owns this. So this Morpheus directory I have is owned by the Morpheus group. Beth is the user that owns it, but Morpheus is the group that owns it. And if you are a member, if your user account is a member of the Morpheus group, you have read and write access and execute access to the Morpheus directory. The last set of three is the other, meaning world or anybody. The other permissions aren't identified here because that's anybody that could connect to this computer remotely. That means through a web interface or through FTP or being a generic third variable on how permissions can be assigned on a system. We'll explore that later as well. So again, read, write, and execute are the three permissions. Now let's take a look how we assign those permissions, and we'll play around with this concept later as well. Read has a binary value of 4. I'm sorry, not binary value, but if we turn the read bit on, it can be either in an on state or off state. If it's turned on, it has a decimal value of 4. Write has a decimal value of 2, and execute has a decimal value of 1. So altogether, read, write, and execute add up 4 plus 2 plus 1 to the decimal value of 7. So any different variable options here, like this, for the other has a decimal value of 4. This directory has a decimal value of 5. Read has a value of 4. Execute has a value of 1. So 4 plus 1 equals 5. We'll play around with those numbers here later on. So let's get started. First thing we're going to do is demonstrate how to create a directory. I'm going to create a directory on the root of the file system here called tank. Make directory tank. If I do a directory listing, I can see my tank directory by default, because I am root on this system, I own that file now, and that file's been put into my group. That folder has been given read, write, and execute permissions for the owner, which is me, root. The group has been given read and execute permissions. The group root, the only members in that group root are me, the root user. And then everybody, the world, or any other user on this computer can read that directory and go into it, open up that directory and see the contents. So, to test that theory, I'm going to log in as Bob on this system. I'm going to use SSH, Bob, and the IP address of that computer. Type in Bob's password and change directory, do an ls-l, and you can see Bob can see that there's a directory called tank, and he is now going to change directory into tank, cd space tank. So Bob can access the tank folder. Going back to the root user, I am now going to make a group called tank. So I'm going to do group add tank. So now my group tank exists. As a review, the tank group has been added to the etc group file. So if I cat the etc group file, I can see at the very end I have my tank group, and the group ID is 1012. So now that I've added the group tank, I want to add Bob to that group. So I'm going to do a user mod -g tank to identify the group, and the capital G identifies that I'm going to add the group tank to the user Bob. So now Bob has been added to the group tank. I'm going to take a look at the group etc group file, and you can see Bob is now a member of the tank group. So I am now going to set the permission on the group folder tank so the group tank owns the tank directory. And to do that, I'm going to use the chgroup command, and I'm going to identify tank as the group owning the tank directory. I'm going to do an ls-l, and I will see that the tank directory is now owned by the tank group. The tank group can read and execute. I am going to remove everyone from having access to this tank folder by removing these permissions. So only the tank members of the tank group will be able to see it and access it. To do that, I'm going to use that decimal value of the permissions. 4 for read, 2 for write, 1 for execute. So to do that, I'm going to use the command chmod, and I'm going to use the decimal value. So for the user root, it's going to be 7, and for the tank group, I'm going to set that to 7 as well. I'm going to give them, actually we'll leave it at 5. So 7, 5, and then 0. So 7, 5, 0 for the tank directory. ls-l, see what we did. So now any user on this system will not have access to go into the tank directory. But if you are a member of the tank group, which owns this folder, you will be able to read and execute the contents of this folder. And if you're root, of course, you'll be able to read, write, and execute. Now, a little caveat about root. Root ignores all permissions. Even if a folder or directory or a file has no permissions set on it, root will still be able to access all of those files and all of those directories. Let's test out what we just did. Now, Bob I added to the tank group, which means Bob's going to need to disconnect from this computer and reconnect to get the new user settings that we just set up for him. So I'm going to type exit, Bob logs out, and I'm going to reconnect. Now Bob has read the new permissions and the new group ownership identification that we made changes for him, and now he should still be able to get into the tank folder. And here I am in the tank folder. I can access it. Do an ls-la, I can see all the contents of tank, and I can see it just fine. Let me log in as Tom now. Tom's another user. We haven't modified or messed around with Tom. So we're going to log in as Tom on my computer using SSH. And I'm going to change directory back to the root of my file system. Do an ls-l. And I can see the tank directory, but because I'm just the user Tom and I'm not in the group tank, I should not be able to get into the tank directory. Permission denied. So, if I want Tom to have access to the tank directory, I have to add him to the tank group. Well, I'm upset as Tom, so I'm going to exit out. I don't have access what I need to. I'm going to talk to the root network administrator, root administrator for this system, and say, add me to the group, please. So we're going to do a little modification. We're going to do a user mod -g tank for the user Tom. So now if Tom logs in, Tom should now be able to change directory to tank, just like Bob. Alright, so now let's take a look at some file permissions. Bob is going to create a script, and we're going to use the vi command, vir.dir.sh. What this will do is create a file called directory.sh in this directory. And just to test this, I'm going to hit I to insert, and I'm going to use the shebang /bin/bash. And I'm going to do a ls-l long listing and make it colorful. And when I do a shift:\wq, it says cannot open file for writing, meaning if we take a look, the group tank only has read and execute permissions. They cannot write files inside of that folder. So I am going to have to quit with an exclamation mark to get out and not make any changes. Here I am as the root user. I am now going to change the permissions. So we're going to do a chmod 770 for the tank directory. So now I should be able to go in as Bob and create my script. Shebang bin dash ls -l -color, and I was able to write and create that file. So now if I take a look, I'm the user Bob, and I'm happy that I have my shell created. Well, in order for a file to be executed, a script or a program needs to be executable. And if I take a look at the permissions of this file, it is not executable. So I need to change this file so it is executable for Bob, so he can execute this script. So to change this file, we do chmod, and we're going to make it 774. And again, that's 7 for the user, 7 for the group, and then leaving it only read access for everyone else. Whoops, I can't hit enter. I got to identify what I want to do this to. The directory shell. Now if I do a directory listing -L, ooh, it's now colorful because it's now executable. So to execute this script, I have to type / because I'm in the current folder, dir.sh. And what it does is an ls-l, just like we did before, but I executed the /dirsh. Now, let's go see what Tom can see. Tom's in the tank folder. Present working directory is tank, ls. We see the dir.sh. Well, Tom is pretty excited about this. He wants to be able to execute this script too. /dir.sh. Permission denied. Well, Tom is in the tank group, which means he has read, write, and access, or read, write, and execute to everything that's inside of it. Let's take a look here real quick. Bob is the one who created this file, so Bob owns it, and Bob's group is the one who created this file, so Bob's group owns it, which means that Tom can only read it. Well, let's take a look. Tom wants to see what's inside of this. Use cat dir.sh. Yep, I can read it. I'm Tom because I'm an other user having the other permissions. So what I have to do is do a ch group, change the group ownership of this file to tank for the dir.sh file. Now, if I'm Tom, I should be able to execute it. And there I am, able to execute it. So we went through a few of the commands to make modifications to files, folders, and directories. We'll play around a little bit in the next video on modifying a sticky bit. So any files or folders that are created inside of the tank directory will stay owned by tank. So all the users of that group tank will be able to read, write, and execute files inside of the tank folder. Hope you enjoyed and understood a little bit more about file and directory permissions.